You know, we always hear that space is infinite, right? But what if? What if that's not the whole story? What if there's an edge, a literal wall at the end of everything we know? Well, today, that's exactly where we're going. We're going to push right up against the limits of what we can see, what we know, and even what we can possibly imagine.
And that brings us to, maybe the biggest question anyone can ask. It completely flips our whole idea of our place in the cosmos on its head. So what is out there? What lies beyond the edge of everything we can possibly see? Okay, so to even start tackling a question that big, we have to face a kind of tough reality first. Our view of the universe, it's not infinite. Nope. It's more like we're surrounded by these invisible walls, you could say. They put a hard limit on how far out we can look. This cosmic bubble we're in, this is our home, and it has a name, the observable universe. So what exactly is this observable universe anyway? Well, the easiest way to picture it is to imagine we're inside a giant bubble, right in the center. Now, this bubble isn't made of anything real or physical. Its boundary is defined by light. Basically, it's everything, every single star, galaxy, you name it, whose light has had enough time to travel all the way to us here on Earth since the very beginning of the universe. It's our little cosmic neighborhood. But here's the key thing to remember. It's not the whole universe, not by a long shot.
But hold on, because right away we run into something that sounds impossible, a total paradox. If the universe is 13.8 billion years old, shouldn't the edge of what we can see be 13.8 billion light years away? Makes sense, right? So how on earth is the radius actually a whopping 46.5 billion light years? The answer is, well, it's one of the most mind-bending ideas in all of science. Space itself is expanding. The very fabric of the universe is stretching. So while that ancient light was making its long journey to us, the space it was traveling through was stretching out, kind of like a cosmic rubber band, making the trip way, way longer.
And believe it or not, it gets even weirder. It's not just one cosmic wall we're talking about. There are actually 3 different kinds. First, you've got the particle horizon. Think of this as our past. It's the edge of everything whose light has had time to get to us so far. Then there's the event horizon. This one is all about the future. It's a line out there where if something happens beyond it right now, we will never see it. Ever. The light will never reach us. And finally, there's the Hubble horizon. This is the point of no return happening as we speak, where stuff is already moving away from us faster than the speed of light. Yeah. These are the real walls of our cosmic prison, so to speak.
So, okay, we're boxed in by these different horizons. Does that mean we're totally stuck? Completely blind to whatever's on the other side? Well, not quite. See, scientists have come up with some incredibly clever ways to kind of peek over the wall. We can't just look past the edge directly, of course, but what we can do is search for clues that were left behind and even listen for echoes from the dawn of time itself.
And our absolute best clue, by far, is the oldest light in the entire universe. It's called the cosmic microwave background, or the CMB for short. The best analogy? It's the universe's very first baby picture. Seriously. For the first, 380,000 years after the Big Bang, the whole cosmos was just this hot, dense, soupy fog that light couldn't escape from. The CMB is literally the first flash of light that broke free when that fog finally lifted. It's an actual snapshot of the entire universe when it was just a tiny infant. And when we finally got a good look at that baby picture, well, what we found was absolutely shocking. Those tiny, tiny temperature differences in that ancient light, they revealed the recipe for the entire universe. And let me tell you, it is a strange one. It turns out that everything we know, everything we can see and touch, you, me, the stars, the planets, all of it, that's less than 5% of what's out there. The other 95%? It's made of 2 things we know almost nothing about: dark matter and dark energy. But it's not just about light anymore. We actually have totally new ways of getting messages from the cosmos. Take neutrinos. These things are tiny ghost particles. They're so small and interact so weakly, they can fly straight through planets and stars without even slowing down, carrying secrets across billions of light years. And then there's something even more incredible: gravitational waves. These are literal ripples in the fabric of space-time itself, sent out by massive events like 2 black holes smashing into each other. With these, we can actually hear the universe. It's not just about seeing anymore.
Okay, so we've journeyed out to the edge of space.
Let's switch gears and travel to an even deeper, more profound boundary, the edge of time itself. What's the ultimate fate of everything? How does this all end? Now, the numbers here, they're beyond comprehension. We're talking about 100 trillion years from now, when the last stars will finally burn out. The stelliferous era, the age of stars, will be over. The universe will just become this cold, dark graveyard of stellar remnants, things like white dwarfs, neutron stars, and black holes. And then, after a length of time so long it's basically meaningless to us, even those black holes will slowly evaporate away, leaving behind nothing.
So how does this final act actually play out? Well, scientists have a few leading theories. One is called heat death, which is this slow, lonely fade into a cold, dark, empty nothingness. Then there's the Big Rip, a way more violent ending. In that scenario, dark energy goes wild and literally tears everything apart, galaxies, stars, planets, right down to the atoms themselves. And then you have the Big Crunch, which is the exact opposite. Gravity eventually wins the tug of war, and the whole universe collapses back down into a single point.
So we've gone to the edge of space and the end of time. For this last part of our journey, let's go for the biggest mystery of all. If the Big Bang was the beginning of time, space, everything, does it even make sense to ask the question, what came before?
And that question, it leads to a possibility that's just completely mind-boggling. Was our Big Bang a total one-off? The absolute start of everything, period? Or could it be just the latest thing to happen in some grand eternal cycle of cosmic death and rebirth? Now look, we can't prove any of this yet, but theoretical physics has some absolutely wild ideas. There's the Big Bounce, which suggests our universe basically bounced back from the collapse of a previous one. The oscillating universe idea is similar, but it's an endless cycle of bangs and crunches. Some physicists even talk about multiverse collisions, the idea that our whole universe was born when two higher-dimensional brains slammed into each other. And then there's loop quantum cosmology, which says maybe there was never a singularity at all, but a quantum bridge that smoothly connected a contracting universe to our expanding one. So our trip to the edge of space and the end of time, it's brought us right back around full circle to the beginning again. Of course, we don't have all the answers, not even close. But just searching for them, that's what expands our minds. It reminds us why we have to keep looking up and keep wondering. Because, in a universe that might have infinite possibilities, maybe the biggest discovery isn't what's at the edge, but the idea that every end might just be another beginning.